Good morning, parents, teachers, and learners. Welcome to Valenzuela Live. I am Miss Gretchen May G. Mendiza from Valenzuela National High School. We are now on our week 3 of quarter 4. We are going to discuss the lesson 4 of your statistics and probability learning packet. Our topic for today is about the test statistic. For today's lesson, you will learn to computes for the test statistic value, draws conclusion about the population mean based on the test statistic value and the rejection region, solves problems involving test of hypotheses on the population mean. Before we begin the lesson proper, I would like you to meet Dora. She is finding her way home, but the statistics wizard blocked her way. The wizard speaks to Dora, saying, "You were told not to go out since the virus is still out there, but you still did. For your punishment, I put barriers on your way home. You need to correctly answer the questions on each block to remove the barrier. Good luck." Dora says, "G." Dora is a strong and a smart child, but she can't do it alone. She needs us. Let us help Dora in answering the questions later. Let me just remind you that you only have 5 seconds to answer each of the questions. Here is the problem. You better take down notes so you can answer the questions later. I assure you, this is not as easy as you think. Problem: a pool of researchers claims that the average age of schooling among children in a certain district is 4.8 years, with a standard deviation of 0.91. A preschool teacher attempted to verify this claim by taking the ages of 360 first-time schoolers in the said district and found out that the average age is 4.12 years. Suppose that an appropriate test statistic revealed a value of negative 14.18. Is there enough evidence to support their claim at 95% confidence? After reading the problem, Dora is excited to answer the first question on the barriers. The question goes like this: what test statistic must be computed to test the claim of the researchers? Is it z-test or t-test? 5 seconds. Dora's answer is z-test. Z-test is the correct answer. The first barrier disappeared. Dora continues to walk on second block. She opens and reads the question. Is the test statistic two-tailed or one-tailed? 5 seconds. Dora's answer is two-tailed, and she is right. Dora continued to walk on third block. Then she reads the question. What must be the appropriate critical value if 95% significance level was used? Is it positive negative 1.645 or positive negative 1.96? 5 seconds. Dora answers positive and negative 1.96. Again, she answered the third question correctly. She walks again until she reaches the fourth block. How do the absolute values of the test statistic, or TS, and the critical value, or CV, compare. Is it the test statistic is less than the critical value, or the test statistic is greater than the critical value? 5 seconds. Dora's answer is the test statistic is greater than the critical value. The barrier disappeared as she got the right answer. Finally, Dora is on the last barrier. Without hesitation, she reads the question. Is the computed value fall in rejection region or in acceptance region? 5 seconds. For the last question, Dora answers rejection region. She answered all the questions correctly. And finally, she is at home. Let's now proceed to the next part of our lesson. I prepared an activity to answer. This activity is entitled React on Me. You're going to react hard if the computed test statistic fall in the accepted region. And you're going to react light if the computed test statistic fall in the rejected region. Are you ready? Let's begin. First question. The critical value is positive negative 1.96 and the test statistic is 3.98. Is it a heart or a like? 5 seconds. Correct. The answer is a like reaction because the test statistic of 3.98 is located on the right side of critical value of 1.96, which fall in the rejected region. Second question. The critical value is negative 1.28 and the test statistic is 1.28. Is it a heart or a like? 5 seconds. Yes, the answer is a heart reaction because the test statistic of 1.28 is located on the right side of critical value of negative 1.28, which is the unshaded part, so it falls in the accepted region. Third question. The critical value is 1.645 and the test statistic is 0.12. Is it a heart or a like? 5 seconds. The answer is a heart reaction because the test statistic of 0.12 is located on the left side of critical value of 1.645, which is the unshaded part. So, it falls in the accepted region. Fourth question. The critical value is positive negative 2.575 and the test statistic is negative 0.96. Is it a heart or a like? 5 seconds. The correct answer is a heart reaction because the test statistic of negative 0.96 is in the unshaded part. So, it falls in the accepted region. And the last question, the critical value is negative 2.33 and the test statistic is negative 6.35. Is it a heart or a like? 5 seconds. Very good. The correct answer is a like reaction because the test statistic of negative 6.35 is in the shaded part, so it falls in the rejected region. In the previous activity, we learned about critical values and their role in establishing the rejection region. To complete the scenario towards arriving with a certain decision on whether to reject the null hypothesis or not, one must be able to compute for the test statistic accurately. The calculation of the test statistic mainly depends on whether the population standard deviation is known, as well as on the size of the sample. There are two main statistical tests performed concerning the population mean. They are known as the z-test and the t-test. Here is the guide questions to know what test statistic we will be using. First question, do you know the population standard deviation? If yes, check the sample size. Is the sample size above or equal to 30? If yes, use the z-test statistic. If the sample size is below 30 and the population standard deviation is known, use the t-test statistic. But if the population standard deviation is unknown, use the t-test statistic. In this lesson, we introduce the formula and the procedures for computing an appropriate test statistic, which will be used to arrive at a correct decision that may eventually lead to sound conclusions. The formula for the z-test statistic is given by z is equal to x minus mu all over sigma divided by square root of n, where x is the sample mean, mu is the hypothesized population mean, sigma is the population standard deviation, and small letter n is the sample size. The formula for the t-test statistic is given by t is equal to x minus mu all over s divided by square root of n, where x is the sample mean, mu is the hypothesized population mean, s is the sample standard deviation, and of course, n is the sample size. After computing for the appropriate test statistic, a decision must be made. To produce a correct decision, we follow the following rule. If the absolute value of computed test statistic is greater than or equal to the critical value, the null hypothesis is rejected. And if the absolute value of computed test statistic is less than the critical value, we do not reject the null hypothesis. After deciding, we proceed to writing sound conclusions. These are inferences that we can draw from the context of the situation based on whether we have to reject the null hypothesis or not. To illustrate how we compute test statistics and write conclusions, let us have the following examples. First example, previous records reveal that the mean salary of the high school teachers in a municipality is 16,250 pesos with a standard deviation of 1,400 pesos. A sample of 50 teachers were taken and was reported to have a mean salary of 18,000. At 95% confidence level, do we have enough evidence to believe what the records revealed? To solve, first, let us identify the test statistic to be used using these guide questions. Do you know the population standard deviation? Yes, the population standard deviation is given which is 1,400. Next question. Is the sample size above 30? Yes, the sample size is 50 teachers, which is above 30. So, we will use z-test. Using the z-test formula, z is equal to x minus mu all over sigma divided by square root of n. Substituting the given to the formula, we have z is equal to x, or the sample mean, is equal to 18,000 minus mu, or the population mean, is equal to 16,250 all over sigma, or the population standard deviation, is 1,400 divided by square root of n, or the sample size, the square root of 50. Performing the indicated operations, we get z is approximately equal to 8.839. We use approximate symbol instead of equal sign because we rounded up the final answer. Next is to find the critical value. At 95% confidence interval with two-tailed type of test, the z critical value is positive negative 1.96. Compare the absolute value of computed test statistic and the critical value. Since the computed test statistic is 8.839, is greater than the critical value of 1.96, we reject the null hypothesis. Rejection of the null hypothesis implies that the selected high school teachers have significantly different salary as compared to the population, and so there is no enough evidence to believe what the records have revealed. Let us proceed to the second problem. A medical report claims that the number of infections per week at a certain hospital in a province is 12.7. A random sample of 9 weeks had a mean number of 11.4 infections with a standard deviation of 0.6. Is there enough evidence to support the claim at 95% confidence level? Again, to solve, let us identify first the test statistic to be used using this guide question. Do you know the population standard deviation? No. Given that sample size is 9, which is less than 30, and the population standard deviation is unknown, we compute for the t-test statistic. Applying the formula for this test value, we have the following. T is equal to x minus mu all over s divided by square root of n. Substituting the given to the formula, we have t equals x, or the sample mean, is 11.4 minus mu, or the population mean, is 12.7 all over s, or the sample standard deviation, is 0.6 divided by the square root of n, or the sample size, which is 9. Performing the indicated operations, we have p is equal to negative 6.5. Next is to find the critical value. In finding the critical value of t-test statistic, we need to find the degrees of freedom. The degrees of freedom, or DF, are the amount of information your data provide that you can spend to estimate the values of unknown population parameters and calculate the variability of these estimates. The degrees of freedom for one population parameters is n minus 1. Since the sample size is 9, df is equal to 9 minus 1 or DF is equal to 8. At 95% confidence interval with two-tailed type of tests and DF is 9, the T-critical value is positive, negative 2.306. Compare the absolute value of computed test statistic and the critical value. Since the absolute value of computed test statistic of negative 6.5 is greater than the critical value of 2.306, we reject the null hypothesis. Rejection of the null hypothesis implies that the selected weeks have significantly different number of infections as compared to the population, and so there is no enough evidence to support what the medical reports claim. Let us try more exercises about test statistic. Compute for the appropriate test statistic in each of the following. I am giving 10 seconds for you to answer. Let's start. First given. Sample size is equal to 17. X or the sample mean is equal to 8. Mu or the population mean is equal to 7.4. Sample standard deviation is equal to 0.5. 10 seconds starts now. Since the given is a sample standard deviation, then we use t-test statistic. Using the formula of t-test and substituting the given from the formula, we will get t is approximately equal to 4.948. Again, we use approximate symbol since we rounded off the answer. Next given. N is equal to 40. X is equal to 6.24. Mu is equal to 5.11. Sigma is equal to 3.6. 10 seconds. The population standard deviation is known and sample size is greater than 30. Then we use z-test statistic. Using the formula of z-test and substituting the given from the formula, we will get z is approximately equal to 1.985. Third given. N or the sample size is equal to 100. X or the sample mean is equal to 11. Mu or the population mean is equal to 9. Sigma or the population standard deviation is equal to 1.2. 10 seconds. The population standard deviation is known and sample size is greater than 30. Then we use z-test statistic. Using the formula of z-test and substituting the given from the formula, we will get z is approximately equal to 16.667. Fourth given. N, the sample size is 10. X, the sample mean is 5.9. Mu, the population mean is 6.3, and S, the sample standard deviation is 0.125, 10 seconds. Since the population standard deviation is unknown, and we have standard deviation given instead, then we use t-test statistic. Using the formula of t-test and substituting the given from the formula, we will get t is approximately equal to negative 10.119. Last given. N, or the sample size, is equal to 48. X, or the sample mean, is equal to 10.27. Mu, or the population mean, is equal to 9.4. And S, or the standard deviation of a sample, is equal to 2.04. 10 seconds. The population standard deviation is unknown. Instead, we have the sample standard deviation given. Therefore, we use t-test statistic. Using the formula of t-test and substituting the given from the formula, we will get t is approximately equal to 2.955. Good job, students! Now it's your turn. Let us solve the following problems. In the population, the average IQ is 100, with a standard deviation of 15. A team of scientists wants to test a new medication to see if it has either a positive or negative effect on intelligence, or no effect at all. A sample of 30 participants who have taken the medication has a mean of 140. Did the medication affect the intelligence using 99% level of significance? To solve, let us identify the test statistic to be used using this guide question. Is the population standard known? Yes or no? 5 seconds. Yes, the population standard deviation is given, which is 15. Next is the sample size is greater than or equal to 30? Yes or no? 5 seconds. Yes, the sample size is 30 participants, which is equal to 30. What test statistic are we going to use? Is it a z-test or t-test statistic? 5 seconds. Correct. We will use z-test statistic. Using z-test formula, we have z is equal to x minus mu all over sigma divided by the square root of n. Substituting the given from the formula, we have z is equal to x, or the sample mean, is 140 minus the population mean is 100 all over sigma, or the population standard deviation is 15 divided by the square root of n, which is 30. What is the value of computed test statistic? 5 seconds. Correct. The computed z-test statistic is approximately equal to 14.606. Next is to find the critical value. At 99% confidence interval with two-tailed type of test, what is the z critical value? 5 seconds. Correct. The critical value is positive negative 2.575. Compare the absolute value of computed test statistic and the critical value. Is it greater than or less than? 5 seconds. Since the computed test statistic of 14.606 is greater than the critical value of 2.575, what will be our decision? Is it to reject the null hypothesis or not to reject the null hypothesis? 5 seconds. Yes, we will reject the null hypothesis. Rejection of the null hypothesis implies that the new medication affects the intelligence of the selected participants. Now, let's try the second problem. In the population, the average IQ is 100. A team of scientists wants to test a new medication to see if it has either a positive or negative effect on intelligence or no effect at all. A sample of 10 participants who have taken the medication has a mean of 120 with a standard deviation of 30. Did the medication affect the intelligence using 99% significance? First, let us identify the test statistic to be used using these guide questions. Is the population standard deviation known? Yes or no? 5 seconds. The population standard deviation is unknown, but the sample standard deviation is given. Therefore, what test statistic are we going to use? Is it a z-test or t-test statistic? 5 seconds. Correct. We will use t-test statistic. Using the t-test formula, we have t is equal to x minus mu all over s divided by the square root of n. Substituting the given to the formula, we have t is equal to x, or the sample mean is 120, minus mu, or the population mean is 100, all over s, or the sample standard deviation is 30, divided by the square root of n, or the sample size is 10. What is the value of computed test statistic? 5 seconds. Correct. The computed t-test statistic is approximately 2.108. Next is to find the critical value, but we need to solve first the degrees of freedom. What do you think is the value of df? 5 seconds. Correct. The degrees of freedom is equal to 9. At 99% confidence interval with two-tailed type of test, what is the t-critical value? 5 seconds. Very good. The critical value is positive, negative 3.250. Compare the absolute value of computed test statistic and the critical value. Is it greater than or less than? 5 seconds. Since the computed test statistic of 2.108 is less than the critical value of 3.250, what will be our decision? Is it to reject the null hypothesis or not to reject the null hypothesis? 5 seconds. Yes, we will not reject the null hypothesis. Non-rejection of the null hypothesis implies that the new medication has no effect on the intelligence of the selected participants. Great job, grade 11 students. Moving on to our next activity. Decide whether each statement is true or false. Comment T for true and F for false on the comment section. Every question is good for 5 seconds. Let's begin. Statement number 1. We use z-test statistic when the population standard deviation is unknown. 5 seconds. Correct. The statement is false. We use z-test when the population standard deviation is known. Second statement. The inferences that we can draw out of a decision are called conclusions. 5 seconds. Very good. The statement is true. Third statement. If the critical value is greater than the absolute value of computed test statistic, we do not reject the null hypothesis. 5 seconds. Yes, the statement is true. Fourth statement. We use t-test statistic when the population standard deviation is known. 5 seconds. The statement is false. We use t-test when the population standard deviation is unknown. And the last statement, the distribution must be normal or approximately normal so that one can proceed with computing for either z or t-test statistic. 5 seconds. Excellent. The statement is true. Job well done, grade 11 students. I hope that you learned something in today's lesson. For your assignment, answer the assessment part, lesson 4 on page 19 of your learning packet. For questions and clarifications, you can ask your subject teacher during your follow-up discussion. Once again, I am Ms. Gretchen May G. Gementiza from Valenzuela National High School saying thank you, be safe, and God bless us all.